Vector to the traffic pattern in use. Landing runways. Runway 26 left for large aircraft, and runway 26 right for light aircraft. Tower frequency 11.
Every commercial aircraft burns fuel fighting an invisible force called skin friction drag, caused by air molecules rubbing against the aircraft's surface. At cruise, skin friction drag contributes roughly 40 to 50% of total aerodynamic drag, while fuel accounts for 20 to 30% of an airline's operating costs. Even a 1% reduction in drag saves airlines millions annually and prevents thousands of tons of CO2 emissions. Yet, after more than 120 years of aviation, this problem remains largely unsolved.
We are Project AirWorks, an AI-driven adaptive laminar flow control system designed to actively reduce skin friction drag without requiring a complete aircraft redesign.
Project AirWorks combines adaptive riblet-inspired surface elements, localized boundary layer suction, and an AI-based closed-loop system. This system takes pressure and vibration sensors that monitor boundary layer behavior. These signals are then fed into the AI controller that evaluates the flow stability indicators rather than solving full fluid equations. These outputs are then sent as commands to the servo-activated riblet surfaces and variable suction pump. This forms a closed-loop system that continuously minimizes flow instability and delay turbulence on set during cruise.
Today, laminar flow is approached in three ways: natural laminar flow control, and hybrid laminar flow control. Airbus and Boeing rely on natural laminar flow, which uses fixed aerodynamic shaping and works only under a narrow, ideal conditions. Lufthansa's AirShark uses passive riblet films. However, these degrade over time and cannot adapt to changing flow conditions, while NASA and General Electric have demonstrated suction-based laminar flow control. But these systems are maintenance heavy and extremely sensitive to contamination, which leads to a loss of feasibility. All these systems are fundamentally fragile, but Project AirWorks is different. It actively senses instability and then responds in real time to stabilize the boundary layer under real operation conditions.
We operate as a B2B technology provider, licensing our adaptive surfaces and control systems to original equipment manufacturers. These manufacturers then integrate the control system during production. Meanwhile, the aircrafts directly benefit from reduced operating costs and emissions without owning or maintaining any proprietary IP.
Our primary markets are first UAVs and UAS OEMs, but later scaled to aircraft manufacturers and commercial airliners, with secondary markets including cargo aviation, defense platforms, UAVs, and long-endurance drones. These sectors value efficiency gains highly, especially where endurance, range, and fuel costs dominate operational constraints. We enter through UAV and drone OEMs first, where certification barriers are lower and efficiency gains are immediately visible. From there, we scale to demonstration data, partnerships, and licensing agreements with larger aerospace manufacturers, building credibility before entering commercial aviation. Now let's discuss the mathematics behind it. We also plan to use a licensing model for drone OEMs to reduce adoption friction and prioritize credibility over early profit. Pricing includes an upfront licensing fee of $59, non-recurring engineering costs starting at $112 for design adaptation, prototyping and testing, and integration, as well as a recurring royalty of $17.1 per unit delivered. The complete product is sold for $180, which combines licensing and NRE costs while maintaining a 5.8% profit margin aligned with industry standards, which is reinvested into developing. Primary cost drivers include research and development, simulation and development, prototyping, and test hardware, including suction pumps, sensors, and controllers, and integration into aircraft or UAVs. Official certification reflecting the complexity of laminar flow control and boundary layer control.
Project AirWorks is not just about saving more fuel, it's more about reshaping how aircraft interacts with the air itself. By actively controlling the boundary layer, we create a future of cleaner, more efficient aviation without waiting decades for radical redesign. We, Project AirWorks, invite you to join us in transforming flight into something smarter, something leaner, and genuinely sustainable.